In part B, we're asked to then factorise the polynomial. In the first instance, we need to find a substitution of a number into the polynomial that gives a remainder of 0. That would then give us a factor. So starting with substituting in 1, I can see we're going to get 6 lots of 1 cubed plus 5 lots of 1 squared minus 3 lots of 1 minus 2. That gives us 6 plus 5, which is 11, minus 3, which is 8, minus 2, which is 6. So 1 is not a factor. Putting in minus 1, working outwards both positive and negatively, we get 6 lots of minus 1 cubed plus 5 lots of minus 1 squared minus 3 lots of minus 1 minus 2. In this case we have minus 6 plus 5 is minus 1, plus 3 is 2, minus 2 is in fact 0. Now, if the substitution of minus 1 gives a remainder of 0, therefore we know x plus 1 is a factor. Once we have this, we can compare coefficients. In this case, x plus 1 multiplied by some quadratic ax squared plus bx plus c must be the same as 6x cubed plus 5x squared minus 3x minus 2. What we're going to do first of all is we're going to compare the coefficients of x cubed on the left hand and right hand side. The only way we can generate an x cubed term here is by multiplying x by ax squared to give us ax cubed. So the coefficient of x cubed on the left hand side can only be a. On the right hand side we can see the only x cubed coefficient is in fact 6. Looking at our x squared terms, on the left hand side the only way we can generate x squared terms is by x multiplying bx, which gives us bx squared, and 1 multiplied by ax squared gives us 1a or ax squared. So we know that b plus a must in fact equal 5, the only x squared term on the right hand side. We know a is 6, so b plus 6 is equal to 5, so b must equal minus 1. Finally, we're just going to look at the constants on either side, and the only way we can generate a constant, or a number in this case, on the left hand side is just 1 times c. So c must equal minus 2, the only value on the right hand side. So substituting these values in, our factorisation now looks like this: 6x squared minus x minus 2. It would be hoped at this stage that the factorisation would then go down to a further 2 brackets, and we can see from this that we're going to get 2 brackets, one with 2x in, one with 3x in, and then we're going to have a plus 1 and minus 2. Hence, we've then factorised the polynomial fully.